Dear students, we want to continue our lessons about stoichiometry or calculation in chemistry. This time is about volumes of solutions and gases. Under similar conditions, equal volumes of gases contains equal number of molecules that we call as Avogadro hypothesis. 1 mole of any gas occupies a volume of 22.4 dm if we measure at our STP. And if we measure the volume of the gas at RTP, then the volume of 1 mole of gas is 24 dm cube. STP stands for standard temperature pressure, that is 0 degrees Celsius and 1 atm. Meanwhile, RTP is room temperature pressure. Room temperature is 25 degrees Celsius and pressure of 1 atm. This is the molar volume of gases. The concentrations of an aqueous solution may be expressed either as mass of solute per dm cube of solution or gram per dm cube, or B, mole of solute per dm cube. We call this as molar. Capital M, mole divided by volume. The number of moles, or N, of a solute can be calculated from the relationship N mole is C concentration or molarity times volume. The volume of solution in dm cube and N in mole. When we have one solution, we add with water, we get a lower concentration solution. Then the process we call as dilution. We have concentration or molarity times volume for the first solution that we add with water equals the concentration or molarity of the second solution times volume for the second solution. As we know, N is M times volume. Why? M1 times V1 equals M2 times V2, because M1 V1 is N1 or number of mole of the first solution, mole of solute. When we add water to a solution, then the number of the mole of the solute will be the same. Here we have question 1. Calculate the volume of CO2, this time for gas. Volume of CO2 at STP. For STP, 1 mole of gas occupies volume of 22.4 dm cube. By decomposing 15 grams of CaCO3. This is the equation of decomposition of calcium carbonate, CaCO3, producing calcium oxide, CaO, and carbon dioxide, CO2. Here we have the information. The data is the mass of CaCO3, 15 grams. So we can calculate the mole mass over mR. The mass is 15, and then the mR of CaCO3 is 40 for Ca, 12 for C, and oxygen 16, the AR. But there are 3 oxygen, so 16 times 3, or 3 times 16. The mR is 100, so the mole is 15 over 100. We get 0.15 mole. So the volume of CO2 here, the volume of gas is the number of mole times the molar volume. At STP is 22.4. Why we use the mole of CaCO3, this one is for CaCO3, to calculate the volume of CO2. You can see here CaCO3 with coefficient 1 producing 1 CaO plus 1 CO2. So the ratio is 1 to 1. Then the number of mole will be the same. So we have CO2 0.15, also the CaO 0.15. So the volume of CO2 for 0.15 mole is 0.15 times 22.4, because for 1 mole is 22.4 dm cube. If we want to find out what mass of CaO yielding in here, then we can calculate using mass is mole times mR. So 0.15 times the mR is for Ca40 plus oxygen 16, like that, gram. Another example, question 2. Calculate the volume of O2 that is needed to oxidize 20 dm cube NH3 to NO gas. This is the equation. Here you have the data of NH3 20. The NH3 is 20 dm cube. Then the question is the volume of oxygen here. You can see here the ratio is 4 to 5. So the number of oxygen is 5 over 4 times the volume of NH3. This is the volume of NH3. Then we have 5 over 4 times 20 dm cube, 25 dm cube.